and it's my first ever German festival, so it's great to be here. Also seen so many familiar faces and new faces as well. As I've already been introduced, my name is Ismail Mayat. I'm a senior web developer with the Cogworks, and I've been working with Umbraco since 2005, back in the old days of V213. So it's great to be here. And I've done this talk a few times, and I kind of changed the slides a bit with regards to some of the joke slides and the images. And since we are in Germany, and as a Liverpool fan, I have to thank you guys for this man. He's going to win us something. I'm not sure if it's going to be this year, but hopefully, fingers crossed. Any Bayern Munich fans in the house? There's nobody here, so I can't troll them. Okay. Anyway, a bit about the Cogworks, if you haven't already heard about us. We're a .NET digital design agency. We also do content. A number of offices, London, Barcelona, Warsaw, Krakow. So we do Umbraco mostly, obviously. Websites, integrations, intranets. We do stuff with Elasticsearch Mobile. Blockchain. That was me going on a 3-day course and having a bit of a play with it. We couldn't really find anything to use it on, but I thought I'd put that in because it's all the rage. We're a trusted Umbraco specialists. We do conferences. How many have been to the UK festival? Yeah, a couple of you. Okay, cool. We also do the Poland festival in Krakow, which we just had in September. I'm not sure if we're going to do it again next year, but it's kind of on the cards. We also do workshops, which we run at the festival. And we also do Umbraco training. And as mentioned earlier, I wrote the Examine course. How many of you have been on that course? Nobody here? No? Okay, cool. Awesome. Did you do it in the UK? Oh, okay. Fair enough. I'm not even sure who runs it here, but okay, cool. We also do consultancy. Here's some of our clients. There's more than that. Interestingly, Storm, which is a modelling agency for Cindy Crawford and a few others, Veet, which is female hair removal cream. And it's always amazing that when I was working on those projects, the pages that would always break were always the women's models pages and always the pages where you got pictures of ladies' legs. And it was always at the time when my wife would come back from the school run with the kids, walking in, watching me, looking at these pages, trying to fix them. We have quite a few clients, but I think the coolest thing about Cogworks is that we have the world's lamest claim to fame. Who watches Game of Thrones? Any Game of Thrones fans? Okay, a few of you. So a couple of years ago, one of our project managers, because I work from home, I didn't have that much interaction with him. On the day that he was leaving, we went out for a meal, and I was sat next to him for most of the night. So, you have your typical questions of, why are you leaving? Where are you going? He said, I'm going into the movie business. All right, okay, what are you doing? He said, I'm going to become a cameraman. So I said, how have you managed that? He said, well, my sister's an actress. I thought, awesome. Anything good? He goes, yeah, Game of Thrones. I thought, okay, fair enough. Up until then, I'd never watched Game of Thrones. It's only when I got back home and did some Googling I figured out who his sister was. So that was one of our account managers. And before anybody asks, I'm not in touch with him, so I can't get you her number, and I don't know what happens at the end of Game of Thrones. Okay, so we're not going to talk Game of Thrones. Before we get started, a few disclaimers here. It's not an Umbraco talk. However, in Umbraco, we are writing code. Whether you're a back-end developer, you're a front-end developer, you're doing CSS, you're writing code. Any project managers here, or people who project manage? No? Yeah, okay, one or two. It's relevant to you guys as well, because you're facilitating the delivery of code, and that code needs to be clean and adaptable, and we're going to talk about all those things in a bit. There's going to be swearing, only in English, because Brexit. I guess I should have put another extra disclaimer in to bitch about Brexit. And I've had a few people actually speak to me, what's going on over there? What's happening? No idea, because we're just as clueless as you lot. All I can say is the lunatics have taken over the asylum. And we're actually quite lucky just to be here, because I thought, March 29, we're leaving. Are we even able to get into the country or even get back to England? But anyway, there will be some shit animations and images. If you don't understand some of them, just laugh anyway. Okay, so some of the things I'm going to talk about, it may appear obvious, but it's still things that we see time and time again. Also, audience participation. There'll be a few points where I'll be asking you some questions. Please do feedback, or else I'm going to be dying on my feet here. So, cool. So what I'm going to be talking about is about 2 years ago, almost to the day, I attended a 3-day course with Robert C. Martin. Who's heard of him? There's a few of you have read his books and what have you. Or he's also known as Uncle Bob. So he's quite big in the software world. He's been coding since 1969, from working with punch card machines to working with mainframes the size of this room, disks like that big sitting on beds of mercury. It was interesting stories that he was regaling us with throughout the 3 days. So it was a 3-day course, and it was basically distilling, 30, 40 years worth of his knowledge about how to write clean code, things he's picked up over the years. So I'll be talking about Uncle Bob, but also many other sort of giants within the software industry, and sort of distilling and pushing forward some of their wisdoms. And it's effectively standing on the shoulders of giants, really, and just reiterating some of the lessons and things that we've picked up. So yeah, he's one of the things he sort of proposes is about looking at software development as a craft. He uses the word craftsmanship. I don't like that word. I prefer craft because there are male and female developers. And he's also the proponent of the solid principles. He didn't invent them, but he kind of put them together in one of his first books, Agile, C# Agile Practices and Patterns, somewhere along those lines. He kind of collated the solid principles, and we'll talk about those a bit later on. So, clean code and about code quality, why does it matter? Well, we already see, are seeing things like this. And obviously we don't work at that high level, maybe some of you do, I don't know. But that we are starting to see things like this. There's another slide that I saw not too long ago. And I remember seeing a advert for a car, and they were saying, we've written so many 100 million lines of code as a sort of a proud fact that look at our product. It's got this many lines of coding. But as a software developer, this should be making your, the hair on the back of your head stand on end. That this much the lines of code, this many ways for things to go wrong. So yeah, and when it comes to software development, if builders built bridges the way we programmers write programs, then the first woodpecker that came along would destroy civilization. And when it comes to us developers or programmers, the problem is that really you can't tell what a programmer is doing until it's too late. So one of the things about code quality, or one of the sort of real measures for it, is this. That, you get some code, you crack open your favorite code editor, whatever it happens to be, whether it's, you're doing Node, Visual Studio Code, or you're doing C#, whatever it is. You start trawling through that code, and it's like, okay, this is not too bad. I can understand what this is doing. Okay, I can extend things here. Or alternatively, you look at it, and your blood pressure starts to rise. You're starting to kick and scream that, my God, what on earth have we inherited here? Or what was that developer thinking of when he or she wrote this? But the thing is, so I guess we've all seen this. Yep. Over time. The thing is, how many of us have done this? Yeah. And for those of you who put your hands up, thank you very much for your honesty. And those of you who haven't, you're lying, because you have done it, and we have all done it. And it then begs the question that we've seen it, we do it ourselves, why do we do it? So anyway, audience participation time now. Why do we sometimes write shit code? Yeah, that's a good one. We don't understand what it is, what we're working with, or possibly the problem domain that we're in. Anything else?
Diffuse moments.
Yeah. Time's a very good one. Pressure, yeah. Anything else? No? Yeah? All right. First one, we don't understand the problem. So we're working on something, but we don't fully understand what it is that we're working on. This is a good one, working with the latest hipster framework, or as I like to call it, CV and resume-driven development. Whether you're a freelancer or whether you're just looking to move on to the next role. So what we'll do is we'll just pick the first, latest hipster tech and we'll get working with it. Does everybody remember the debacle of the Umbraco version that must not be named? If you go back to that one, there was a blog post by Oren Oreni, who was one of the contributors in Hibernate, and he wrote a whole blog post tearing apart why there was such a performance issue with the version that must not be named. And it was to do with the way that in Hibernate was one of the things, but there was also lots of other things. The other thing is about time constraints. We've got a deadline. We've got a growing backlog. And we need to rush through this, and we're making a mess. But we're thinking, no, it's okay, we'll leave it for later. But as we know, later never comes. So I quite like this quote by Sarah May, that software is messy because it reflects our evolving understanding of the problem as he wrote it. So one of the best bits of software ideally would be is that we've built something and we fully understand what it is that we've done. That's the best time to do the rewrite. Obviously, we can't do that because of budget constraints and what have you. But usually, it's as you're sort of plodding through the problem that you realize, or you start getting insights into what it is that we're supposed to be doing. And again, from Sarah May, that the act of writing software is what drives our understanding of the problem. But we can't just wait and hope for a clean code base later. And the other thing is that a few programmers even write a rough sketch of what their programs will do before they start coding. How often is it that you get your PM come over to you, right, we need this new feature to be added, how long is it going to take? And say, I'll sort it. And you get off to the toilet, which is usually where you have your best thinking cap on. And as you're coming back to your desk, all you're thinking is, right, let's start coding. We're going to start knocking out these classes left, right, and center. We're going to need this. I'm going to need that. I'm going to need, this from NuGet. And very soon we start ending up with a very quick mess, we start to get lost. And in carpentry, you measure twice and cut once. In software development, you never measure and you make cuts until you run out of time. Another reason for crap code is change. We're going to get changes from our client. Now, a couple of years ago, I used to work for an agency. Well, their main business was business to business. In fact, I didn't even fully understand what they did. I just knew the website's part of it. They apparently were a B2B agency, so supplying business to business, I think. That was their core business, marketing, strategy, etc. But as a side thing, they would also do web projects. But that was secondary. So the main money was coming from this B2B stuff, and the side projects were these web projects that we were building in Umbraco. There was always, on the B2B projects, reasonable deadlines and what have you, but with web projects is whatever the client wants, they get, and whenever they want it, they get it. You had nothing like change control. It was always just what they want, that's what they get, and it was constantly changing. And this was adding a lot of load on the developers. So you're working late nights, working weekends, and you're going to be rushing through stuff and making a general mess as you're going along. How many of you heard of the Milgram experiment? It was something that was done in the 60s by psychologists, and it was all about why people do messed up shit to other people. And basically the premise of the experiment was it was in a room, and you had effectively what's like a doctor in a white coat, and they were instructing people or volunteers to electrocute other people in the other room. It wasn't really happening, but it was giving the impression that these people are getting electrocuted. And I think it was something like 90% of the people eventually went to the point where they administered a lethal dose of electricity and would have killed the next person. But as they're doing it, people were hearing these screams and saying, oh, no, I'm not doing it again. And they were using control words to try and force them to actually go ahead and electrocute these people. Now, so in our field, what kind of words do we use in a software engineering context that sort of pushes people and make them do shit code? So things like, again, time pressures. We've got a deadline. Marketing team is going to do a press release next week. Let's push it through. You're not closing enough tickets. Short-term solution, we're going to abandon this code. We need to increase the velocity. Only affects a small number of users. I've got loads of these, so I'm going to go through them. But some of this stuff, there's a really good book that I'm reading at the moment, which I know Carol's reading, The Phoenix Project, which I highly recommend. I've got links to it in the slides. And it kind of covers a lot of this stuff where an organization is getting to a massive mess, and you've got senior people who are pushing things like this, and it's causing the mess. And when we see mess, what we've got to really think about, again, coming back to Carol's talk, whoever was there earlier about empathy, is that we think awful code is written by awful devs, but in reality it's written by reasonable devs in awful circumstances. And again, some of the stuff I'm going to show you in a minute, I think we still need to keep this in mind that, never judge a person until you've walked a mile in their moccasins. However, you see stuff, and we've all probably seen it over the years. So some of the signs of bad code. It takes weeks to do what should take hours. You know, you get your PM to come over, we want some new feature added, and it'll take me maybe 3 or 4 hours tops. And as you start going down the rabbit hole, you start to realize, okay, no, maybe not. You know, one line change touches hundreds of modules. The code itself is rigid, it's fragile, it's opaque, you can't see clearly what it's doing, where it's going. Yeah, and as you look at it, all you're thinking is, what the hell is going on here? It doesn't have a test suite. No one wants to touch it, because you touch it, you own it. And we do have projects like that. And I've worked in organizations where we have things like that. And it's that, I've got to make a change on X, Y, Z. I don't want to do it. Yeah, the other thing about working with bad code is that cognitive load is increased. And what we mean by that, and here's Sweller's definition, that total amount of mental effort being used in working memory. So you're sort of juggling with the concepts of what that code is trying to do, as opposed to the new thing or feature that you need to add to that code base. Bad code is easy to recognize. Clean code is hard to write. And it does require discipline, courage, and skill. Old habits that we've picked up over the years, we need to sort of unlearn some of those. Now, there are some people who are born with code sense, you know, what I call natural born coders, and there are other people like me who really sort of have to work at it. Yeah, you have to work to acquire it, practice some more. So in summary, what is clean code? It's easy, accessible to others, it's straightforward, it's easy to read, there's good abstractions, good names, and these are some of the sort of most common points. Also, the author cares for what they're doing and for other developers, which implies readability and maintainability. In my first role, this was around 1998, one of the developers that I worked with, anytime I looked over and saw his screen and his code, it was so nicely formatted. Everything just looked nice, opposed to what I was writing. Yeah, and the code itself is something minimal. It does one thing, has minimal dependencies, and it's good at what it does. Yeah, and there's no alarms and no surprises hidden in there. Now, I really like this from Sandy Metz, who I'll quote quite a lot of as well. And there's some slides, in the slides, there's some notes of her videos and her book, 99 Bottles of Whoop, which I highly recommend everyone to read. And she came up with this TRUE acronym, that the code is transparent. So the consequences of changes are visible and predictable. You know, you're going to make a change in the code base. You know what it's going to impact. There are no hidden things in that code. The code is reasonable, so that when it comes to adding a new feature, it's proportional to its value. So it means that one of your customers says, we need to add this new feature. I'm sure we've all been in the situation where, sorry, we can't do that. It's not designed to do that. We've already sort of coded in so many things, and to make this one little change, which the client thinks is reasonable, it's going to be very, very difficult to change. The code itself is usable. You rotate, you can use it. Other people can use it as well. And this one is my favorite point. It's exemplary code. More code like this would be good for your program and your application. And it's kind of the opposite of the bad code as described by Bob Martin, which is what we touched upon earlier, this rigid, fragile, immobile. So why is clean code important? Now, this was about 2 years ago when I first did this talk in Poland. 2 days before I did it, I was just following my Twitter, and I follow Venkat Subramaniam. Any of you heard of him? He's really big in the Java world. I kind of like to think of him as the Indian Uncle Bob. He's written a really good book at the moment, which I'm reading, Rediscovering JavaScript. And he did a talk, 12 ways to make your code suck less, and there's a link for this one as well. But this is the thing he said, that we cannot be agile if our code sucks. And what we mean by agile, as defined by the Agile Manifesto, one of the points in there, responding to change over following a plan. If your code sucks and you can't change it, it's rigid, you're not going to be able to be agile. Yeah? And also, you accrue technical debt and low quality. Low quality is not technical debt, but it's technical suicide, particularly if you've got a really big project. You're going to get into making a mess. It's going to come bite you down the line. And the thing about technical debt is, when you're starting on a project, if you're making a mess, you'll start up fast, but as you start going along, your velocity goes down, as opposed to taking the time and putting in the time to actually make sure you've got good code. you'll end up with more higher velocity as you're going along. And I think this slide sums up technical debt that, again, you start off on a project, you're progressing really fast. As you then start to hit a problem, trying to get back, undo things, is going to be problematic for you. Okay, so we're going to go back to the basics and some of the sort of principles that are going to give us the ability to write clean code. First and foremost, naming things. So there are only two hard things in computer science: caching validation and naming things. So ideally, reveal your intent. That, what do we mean by this? Days, dogs, Danish people, developers? I have no idea. When it comes to naming things, think, then think some more, and think again. Isn't that better? Elapsed time in days. So the name of the variable really should tell us the significance of what that variable contains, what it's doing. Now I came across this article, and I've taken the image from that, and it was actually seven or eight blog posts which went into detail of each of these things when it comes to naming things. I'm not saying we follow this rigidly, but get an understanding of how, when it comes to naming things, that, in this particular example, you come up with a nonsense method name, something that's a bit more honest and complete, does the right thing, declares the intent, and then actually models the domain that you're in. And in this instance, it's something to do with airplanes and monitoring flights, but you can see clearly there what it's talking about. And some pro tips: if you're a mathematician, use single variable names, ideally from obscure and dead languages. If you're a programmer, use descriptive names. And here is some real code that we have in a code base that we inherited. Okay, the method name is good. So I know it's something to do with attractions, and there's a search, so I can infer that's probably a query. That's probably a location. No idea, no idea, no idea, no idea. And we've got this bit of mess here. And further down, it calls another method. And in that method is where the actual variable names are defined properly. So I've got to drill down a level just to figure out what that's doing. Avoid disinformation when you're naming things. So when I was on the course, there was one of the delegates on there was somebody who works for the BBC. For those of you who are not from the UK, BBC is one of our national broadcasters. And they have the iPlayer, which you can then stream and watch programs from the BBC. And he was on the iPlayer team, and they wrote that in Node.js. And he was telling me about, when we came to this, he was telling me during break about a particular incident where they were working on a section of code where the developer had left. But within that section of code, there was something that was making a request, and then you were getting a response. But the names of the method and the names of the variables were inverted. So you had to keep in your mind what it was actually doing. And each time, he said, every time I looked at it, my first thing was, okay, request, response. It isn't, it's the other way around. And he goes, before I could do this work, I had to go back and just rename everything so that I could get that out of my head and actually think of the problem domain that I'm actually working on. Use pronounceable names, because you're going to be talking about this code in code reviews. Use searchable names. We have IDEs to help us to search for things. But if it's a meaningless name that isn't very searchable, we're kind of losing that help from our coding tools. So variable functions, class names should answer all the big questions: why it exists, what it does, how it's used. Ideally, classes and objects, they should be nouns, and method names should be verbs. They're actions. And this from Venkat again: if we can't name a variable or a function appropriately, it may be a sign that we've not understood its true purpose. And the other thing that Venkat was saying is that we probably find it easier to name our kids than it is to name our variables and our functions and that kind of thing. So next thing that this brings me on to is functions. So the first rules of functions is that they should be small. Second rule, should be smaller than that. Functions should not be more than 100 lines long. And for this from Bob, ideally, they shouldn't be more than 20 lines long. And longer methods get longer. And they should pass the squint test. Again, this is from Sandy Metz, and she describes this as, get your function or method or whatever it is up on your screen, lean back and kind of squint. Can it all fit in on the one screen? Or is it Hadouken code? Anybody play Street Fighter? Yeah, a few. Yeah, I failed my degree more or less because I did my original degree in chemistry. And every lunchtime, we'd have experiments going. I'd leave them running and just get off to the student union and play Street Fighter. But yeah, Look at this. Not very good. So, yeah, this should be, So again, they should be small. Long functions and methods are hard to track. They lack cohesion in the sense that related stuff isn't there together. You've got all kinds of different things in there. And they'll have high coupling. You'll be newing up objects and things everywhere, and it'll be coupling with other stuff. They're hard to read. They're hard to reuse because you've already pushed in so much stuff into there. And it leads to duplication as well. If you haven't got smaller methods which you can then reuse, you end up with duplicated code. They're hard to debug as well. If you've got a debugger and then you have to scroll up and down as you're trying to track and figure out the particular problem that you're trying to fix. Ideally, they should do one thing and try and follow the step-down rule and top-down narrative. And I'll show you that what I mean by that on the next slide. Ideally, no more than 3 arguments. If you've got more than 3, try and group them together. So the example that I showed you earlier where we had like 7 odd parameters with single letters, that is something to do with a search or attraction search query. We could create an object like that with the properties on there and group them together. Much easier to read than just a whole line of variables going across. Ideally, do not use booleans as a control parameter. It's a warning sign that a function is doing more than one thing. And what we mean by that is something like this. So when you pass in true, it's doing one thing, false, doing something else. And it's not clear what that is doing until you actually go in there and figure out what's going on. So when it comes to the step-down rule, so here's a bad example of it. So the public method, which is the first, the public interface to whatever it is that you're working with, that's down at the bottom. And then the order of the sequence of the calls is you're calling add eggs, cook, and serve. But so you're given an indication of how the I should be following down in the particular file that you have. But here, the order isn't following that. So we've got serve, add eggs, and cook in the wrong way around. But a better way of doing that, which is easier on the I, and which is kind of following your natural flow, is put the public method at the top, and then the order that you're calling these methods, put them in like that as well, because that's what you're going to be expecting. And it's just nice. Looks better on the I, and it's helping people to read that code better. If you can extract a function from a function, then it's doing too much, so do that. Extraction functions for readability. So when you have things like this, you're going to have to, maybe when you first write it, you can figure out what the intent was of that code, come to it 3 weeks later, you're going to have to then rethink, hold on, hour getting a 7, lesson 12, okay, something to do with morning and a message. But is that not better, that you actually extract out the method and straight away you know what that method is doing just by actually looking at the method call? And then maybe later if you want to then go and look at the logic, you can do if there's a problem with it. So the other thing about functions, how many of you have worked with a functional language? Carol, has anybody else? What have you worked with? Okay, JavaScript. Okay, yeah, it is. So one of the things is that now with you're seeing a lot of noise about functional languages, and when it comes to JavaScript, I've seen quite a few talks and books about functional patterns in JavaScript, and also what we are seeing now is there's a lot of stuff from functional languages coming into C#. We've already had LINQ, which has come from Lambda calculus for quite a while. Pattern matching is something that's come in C#8, tuples, and there's other stuff coming as well. But functional programming as a paradigm predates object-oriented programming. It's from around the 50s from Lisp. And what we mean by pure functions is that given the same argument to a function, it should always return the same output, honest signatures, referentially transparent, and they do not mutate state. Now, they also avoid side effects. So there are things that come from functional programming that we can use to make our code better. So for example, this function here is not a pure function. And there's a reason for that. One is that the signature is not referentially transparent. It's doing something else here with this, but it's not indicated in the signature. However, this one, you're passing in everything that it needs, and then you're doing something, so it's referentially transparent. Everything that it's supposed to be doing is clear from the signature here. The other thing with this is, if you wanted to test this method, how do you get around or abstract this and work with this? Are you going to change your clock on your machine back and forth to actually test things? Or can you do it this way, where you're actually passing in the dependency, and then you can set that to whatever value you like? The other thing about functions, avoid side effects. So this is saying it's valid password, you give it username and password, so it's coming to some kind of validation. Cool. It is, but it's also doing this. but you don't know that until you've actually gone in there. Now, this is quite a simple explanation, a simple example of side effects, but you can get more complicated ones where unexpected things start to happen, but looking at the method signature, you don't know that until you actually go in. Again, there's a couple of other links I've stuck in there to do with functional programming and things that we can use to help us write better code. So the thing is, classes, again, classes should be small. Ideally, we want to try and follow the solid principles. Has everyone heard of solid? Okay, there's a few of you. All right, I'm going to touch upon these. This one is the one that's going to get you out of jail the most. A class should take care of only one responsibility. So let's say we've got an example of an employee class. When you are not following the single responsibility principle, the application that you're writing, let's say it's got to write something to the database. Let's say you're going to do some HR stuff with it, some salary calculations, something to do with holidays. That's now 3 reasons for that class to change. When you're first starting out, you'll create this one big God class and shove all the logic, all the functionality in there. When you start applying the single responsibility principle, looking at your classes and thinking, is this doing really one thing? You will soon start to find that you've got other smaller classes hidden away within that code base, and you can start extracting those out and they start doing just one thing, which means the potential, you've got cleaner code, it's easier to read, and it only has one reason to change. These I will just talk over briefly. The open-close principle, that we should try and prefer extension over modification. So for example, let's say we've got a class that is doing one particular action, it works, it's released, it's been tested. We now want to start adding maybe logging or caching. The temptation is to modify that class and add the actual boilerplate code for logging or caching in there. Ideally, we want to create some kind of adapter and a proxy which will make use of the original class, and that new class has the actual login and caching within there. There is a really good video that was done by Kevin Gifskowski where he explains the solid principles in a really simple way with the example of a guitar and the amp, which was really, really good. And there's also an excellent article done by Emma Garland, and she did it for I think it was in one of the 24 days in Umbraco, where we can make use of the solid principles within Umbraco code when we're writing Umbraco classes and views and controllers. I've also got the links for that one as well, which I highly recommend. Again, just to reiterate, with classes and functions, inside every large program, there's a small program trying to get out. Okay, so we're now going to go into the next part, which is controversial waters, because I've seen arguments for and against comments. But what Uncle Bob is saying is that comments are a failure to be able to express yourself in code. So the kind of types of comments that we see, one of my pet hates is commented out code. And the other thing about comments is that it doesn't make up for bad code. I've inherited a project a couple of years ago where they were doing some stuff for tag-based search using Umbraco Examine. They didn't know how to quite get working tags where you have spaces in because of the tokenization. So they came up with their own tokenization scheme, which was the code itself was just about readable. And then they had a whole paragraph of comments explaining what it was doing, except the comments did not tally with what the code was doing. So comments do not make up bad code. And comments can contain lies, as I just mentioned, and they can rot over time. And a common fallacy assumes that authors of incomprehensible code will somehow express themselves lucidly in comments. Compilers do not read comments. Developers do not read comments. Well, maybe when it hits the fan, then they'll read it. Here's an example of misleading comments. Now, imagine getting into that lift and you've got to then sort of juggle that in your head. And you may say, this is just an analogy. It's not a very good example. Here's a real example that Mark tweeted. Oh, was it Mark from Moriyama? What's his surname? Mark Goodson. He tweeted this. So, you see that, what are you going to think? The one for you, Carol. Okay, some more comments. What I like to call the smart arse. This is scary, quick in practice, followed by 4 nested loops. If you see this in a code base, this isn't going to exactly instill you with confidence. This one, School of the Bloody Obvious. I used to work with someone who will remain unnamed, who used to do this all the time. Warren, Cough, Buckley. Yeah, and this kind of stuff. Who doesn't use source control? Does everyone use source control? Awesome. Source control back in the 70s and 80s maybe, and before SVN really took off and Git really took off. Now there is no excuse not to use source control and avoid stuff like this. There will be times when you've got to write valid comments. You're doing some kind of paid product, you've got to have legal information in there. Informative comments, regexes are complex, as they are, and trying to, coming back to one maybe a couple of weeks later, you're not going to understand what it's doing. But I always like to think you never really get better at regex, you just get better at Googling. There could be something that you need to explain. You've done something in a particular way, a particular anti-pattern, or maybe something else, which for the next developer, it makes sense, at least an explanation that why has this been done in a particular way. Warnings. So yeah, crude example, but something's not working or working intermittently, and you need to explain that. To-dos, they help your editor, your code editor, and you can get back and do things. But I always find to-dos always end up as to-don'ts. The other thing about comments, so good code is like a good joke. Writing comments is like explaining a joke. And when Venkat showed this on his talk, he was really incensed by this, that you're insulting my intelligence, that those who can't design are condemned to document or to comment. So the next part of this puzzle is test-driven development. How many of you do TDD? To some extent. All right. So, have a read of that statement, that a software system is best designed if the testing is interlaced with the designing instead of being used after the design. What year do you think that statement was put down? Anyone want to guess? Shout out some years. 50s, okay. Anybody else? Any better on that? No? This is in 1968. TDD is not some new hipster crap that's been around maybe for 10, 20, 30 years. It's been there for a while. And Venkat, when I heard him speak, he was talking about TDD, and he was saying that 20, 30 years down the line from today, we're going to look back and think, did we really write code without tests? And he likened it to, back in the 1800s in hospitals. You wanted to find the best doctor, you found the one with the most blooded overalls, covered in blood, and you would think that this one's the best doctor. But there was such a high death rate. And it was only when they, figured out wash your hands and wash them in a particular way that you had a reduction in deaths. And it's, they just as, for example, in accountancy, you have double bookkeeping as a standard practice, and it's, a rigor. This is the engineering rigor within our industry. So a few things about TDD. Uncle Bob's 3 laws of TDD. First law, you don't write production code until you have a failing test. Second law, you don't write more of a unit test. You may not write more of a unit test than is sufficient to fail. Not compiling is failing. And you don't write more production code than is sufficient to pass the currently failing test. So you're making these small increments, guided increments, and you are then starting to flesh out the design of your code. And I highly recommend watching some of Uncle Bob's videos and read some of his articles where he demonstrates how he does TDD. And also he pairs in another one with Ward Cunningham, who's quite big in the Java world and Smalltalk. And the pair of them working together and how they are using this technique to sort of drive out the design of the code and the logic of it. So the goal of TDD from Kent Beck is that clean code that works. And this was a real eye-opener for me when I read this, that TDD is programming with intent. So rather than the image that I showed you earlier where the cat coding away and just knocking out all these files, you have a small goal in mind, and then you start writing small amounts of incremental code to actually sort of drive what it is that you're doing. And it leads to emergent design. It's also an analysis technique and a design technique for structuring all your activities as you're coding. And the other thing is that once you start getting into it, it's a bit like crack cocaine. It's a dangerous drug, especially that red-green refactor and then in your IDE as you're sort of coding stuff. But there's a slight difference, I would say, from some of these dangerous drugs that are out there. The only thing I'll say that I'd say development is also a drug, except, I think we've all sort of probably been on that end after marathon coding sessions. The other thing I like as an analogy when you're working with tests, that test suite, it's a bit like getting belayed when you go climbing. I used to go climbing quite a lot years ago. And when you climb with a rope and when you free climb, you work in a completely different way. When you are on a rope, you will try dangerous things. You will try jumping across. You will try maybe holding just two handles at the same time and pulling yourself up because you know you've got that safety there. So when you have a test suite, you will be happy to add changes. You will be more confident refactoring. So why testing is important, that until you execute a line of code, you don't know if that code could work. And until you execute that code with a set of use cases, you don't know if the code can work end to end. And also, coming back to refactoring and modifying, you're not going to be too confident doing that unless you're backed up with a suite of automated unit and integration tests. Now, one of the things within Umbraco development, it's quite tricky to actually do proper TDD because of the way Umbraco works. But there are quite a few articles written by Lars Eric, and he's also written a workshop, and you can get the source code for that, which kind of gives you techniques of how you can introduce TDD when you're working with Umbraco. When you're working outside of Umbraco, so not too long ago I was working on a project which was just .NET Core and ASP.NET Web API, and working and doing unit testing and using that to drive the development was really, really sort of cool, really, really easy to do. So testing can also be used in profiling. You can see how performance is changing as you're making modifications. If your tests start to run really, really slow after you've made a change, you can figure out here that I've introduced something that's not very performant. And as I mentioned before, testing is the engineering rigor of software development. So a few things about TDD. It has more refactoring than testing. I think you see the words used interchangeably. You hear test-driven development and test-driven design, and it's kind of both of those. And it's more thinking than coding. This is a really important point. You sit back and you write this test for a particular scenario or a particular bit of functionality. I'm trying to do this, given this, when this, I expect this. So this is in your mind now, and this is what you're trying to sort of code towards, this end goal. And again, from this for TDD, that you make it right. So you make it work, make it right, and then make it elegant as you're going along. So you do the quickest thing first to get you to the green stage, get it working, then you start refactoring to actually make it more expressive. And this is why it leads to better code quality. I'm not saying that you're going to end up with no bugs, whatever, but you will have less defects, but you will have something which you will have more confidence in being able to change. Now, a common refrain you hear that this code cannot be tested. What you're really saying is that this code is badly designed. I have no idea this works, or I have no idea how this code works. Now, we may already have legacy code bases. Maybe we want to introduce testing into those. So one of the things you can do is write an integration test. So this could be something that runs really slow. It could be with Selenium. It's testing a whole registration functionality, let's say, make sure that that works. And then you can start picking apart and introducing tests. Now, there's a really good section in the Art of Unit Testing book, which I'll show later, and there's something called the test feasibility table, and you can look at that and how you can then introduce tests into an existing code base. And there's a really good blog post by Mark Seaman about what to test and what not to test. So moving on, when you have bad code, you also have code smells. Has everyone heard of code smells, or the terminology of code smells? Okay. Can anyone name me some code smells? Or categories of code smells? Right, I'm going to run through these very quickly. So you have things like bloaters, which we've kind of already talked about in functions and classes, long methods, large classes, primitive obsession, long parameter lists, clumps of data that have been passed around together, stuff that abuse object orientation, switch statements, which means you've usually got some kind of logic that you could extract out. I won't go into all of these, we're kind of running a bit short of time, but what I wanted to show is that there are quite a few of these. We've had people with more experience who have gone through the pain and figured all this stuff out, documented it, and then showed us how to fix it. So knowing these categories of things and recognizing these things, we can make use of, there's a few more of these. Right, we can use textbooks that are out there and also videos to help us to clean up our code. So the first thing is really to recognize that we have these problems, and thankfully there are people out there who have also had these problems and have documented them. And I highly recommend the Refactoring Book by Martin. Has anyone read that one? Martin Fowler's Refactoring, the second edition, highly recommend. And then there's also Refactoring to Patterns, how we can, and then there's this cheat sheet where it details all these anti-patterns, and then it refers back to these two books and giving you recipes on what page and how you can fix these things. So just to finish off, the final advice, and this is again from Uncle Bob, is that the Boy Scout and Girl Guide rule, that leave your code better than you found it, and that the act of leaving a mess in code should be socially unacceptable as littering. One for you, Carol, again. Always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. It's a bit harsh. I prefer this one. Code as if the person who's going to end up maintaining your software is your best friend and you want them to be really proud of knowing you. So there are these problems with bad code, and what can we do to sort of address some of these issues? So one of the things we can do is code reviews, and Carol talked about them at her talk earlier in empathy, and it's such an important point to have empathy in your code reviews. So when we first introduced code reviews to Cogworks about 2 years ago, so when we work in an agile way, we work on features. When a new feature is ready to be delivered, before it goes into testing, we do a pull request, and 3 or 4 developers added to that pull request, and we then go through it. Now, the first time we did it, one of our developers, Ali, who's not renowned for being very, how should we say, what's the word I'm looking for? He's quite coarse. So it was like, this code's shit. What are you doing? I don't understand it. And these were the comments he was putting back. And then he went and rewrote the guy's code. And so there was a big fight going on that we had to sort of diffuse. And when it comes to code reviews, ego's got to go out the window. So just 2 days ago, I'd put something to a pull request on one of my classes. 2 of the properties I thought were named okay. And one of the developers who's only been here with us for 2 years, and he pointed out this isn't right. I had to say, yeah, he's actually got a point there. And so I went and renamed things. So do try and implement some kind of process like that where we do code reviews, but use empathy, I think, and common sense, and be how should we say? There's 2 ways of saying things. One is that's shit, or that's okay, but maybe I would have done it like this. There's ways of saying things. So do use that in your code reviews. Also, try and implement pair programming, which we can't try and do. When you have downtime, try and address technical debt. In your code base, find things which maybe doesn't quite look right, or even the current thing that you're working on. If something there which is going to be quick to fix that out. What I like to think about addressing technical debt and fixing code is a bit like in New York, they did a study about old places where people were smashing windows. And if the window was left unrepaired, more windows would get smashed. But if they went back and fixed them, there was a drop in the rate of windows being smashed. When you have code which looks nice or is improving over time, you're going to make sure that code base, as you're putting new stuff in, you'll put it in a nice way. There's something Sandy Metz in her book addresses about this, that code, once it's there, it kind of influences the next person who's coming along. If they see a mess, they're just going to put in another mess. If it's already nice and neat and clean, they will feel obliged to keep it nice and neat and clean. So again, coming back to this, no matter how slow you are writing clean code, you will always be slower if you make a mess. And any fool can write code that a computer can understand. Good programmers write code that humans can understand. So in summary, you're responsible, or feel yourself to be responsible for code quality. Use meaningful names, code that expresses intent. Code should speak for itself. Less comments equals less maintenance. And leave the code better than you found it. So as you're checking stuff out, if there is something that doesn't quite look right, do fix it up. Again, try and work to the solid principles, but really this one is very straightforward and easy to understand. Look at that code or that class. Is it doing more than one thing? There'll be other things hidden away in there that you can extract out. And try and do test-driven development. I know it's quite difficult when you're working within Umbraco, but there are ways around it. And it's programming deliberately with intention. And master your craft, read books, read code. These texts that I will show you in a minute are classics. And so the other thing to sort of understand is, as a software developer, you're your own worst enemy. If you write crap code, you're going to come back in 6 months and you're going to be the one who's going to be fixing it. So do yourself the favor. And this was an interesting interview with Uncle Bob. What's your biggest passion these days? He said, keeping the code simple, clean, well-structured, and well-tested. And this I saw just literally the other day. Complexity is an engineering fetish, and nothing strokes the ego more than building and maintaining and talking about some sort of ridiculous system. We like to introduce complexity because it makes us look clever. And this was from a commit into a Linux repo. And this is the bit that sort of struck me, that complexity is such a bright candle for us hacker moths. We want to try and avoid complexity. So there's a lot to take in on those slides, and you can delve a lot more deeply into things. And I highly recommend, I'll share the slides out after, but there's quite a lot of books and articles and videos which you can watch and read in your own time. So Clean Code, obviously, which is the one by Uncle Bob, which covers in detail a lot of these sections that we talked about. This is the sort of de facto text on getting started with test-driven development. And if you're in the .NET sphere, which is where we are, highly recommend Roy Oshergrove's Art of Unit Testing. And if you want to look at more about how you architecture code at a higher level, Clean Architecture is really good. But, so the Clean Code, Test-Driven Development, Clean Architecture book, if you don't want to read those 3 books, I highly recommend Adaptive Code by Gary McLean Hall, the 2nd edition. I was lucky, I won this at an Umbraco-Festival, Umbraco meetup in Manchester. I didn't even know he was speaking. They got him to speak, and I got it signed as well, which is awesome. I'll be flipping that in eBay at some point. The other classic text is Refactoring. This one, I think it came out originally in 2002 or something like that, and then it was rewritten for a 2nd edition, which came out just a couple of months ago. Highly recommend it. That's me. Any questions? No? But I'll hand the slides out, and you guys can sort of look into a bit more depth of the different topics that we kind of covered. Thank you.